And now we will jump over. Okay, we all see my screen? We can talk. We can talk now. I can hear you guys now. Oh no, Joshua, your microphone's not broken. Okay, so let's see. Okay, so here's our first proof. So just so you see, this whole section covers all the benchmarks for that include proofs. So here we have one. So the steps of a proof are shown. So you have that angle A and B are parallel. That's given to me. So even though we're only really looking for the reason for step 4, I kind of want to fill in the reasons in the previous steps. So in the first step, my reason is given, right? And then my second step says angle 1 and angle 2 are congruent. Why would they be congruent?
Alternate interior.
Beautiful. They are alternate interior angles. So alt interior angles theorem. Oh, I definitely didn't spell that right. Theorem. So notice how I don't need to know the exact name of it. I just need to notice that they're alternate interior angles. Okay. And then from there, I can just figure, oh, well, obviously that's going to be the one, right? Now, 2 and 4. 2 and 4 are what?
Transitive?
Yeah, transitive.
Why are we saying transitive?
Wasn't it? You said
exterior.
What are we saying?
Alternate exterior.
Okay, so Ty says alternate exterior.
Oh wait, no, sorry, that's wrong. They're supplementary though.
Are they?
Wait. Oh my God, sorry, I'm looking at the wrong one. Oh my God, sorry.
Isn't transitive like if
Yeah.
it's if
No, wait, they messed this up.
Oh, well, yeah.
Sorry, I was looking at number 20. I was looking at the wrong thing.
Oh, oh, we'll do that one next. Okay, wait, hold on. 1 and 2 are alternate interiors. And then
transitive is like A equals B, B equals C, so
Yeah,
A equals B.
just about to say that.
yeah, they messed up here because so you see how in step 3 to step 4 suddenly they bring up angle 3.
Yeah, a little weird. Notice that. Yeah.
Right. So angle 3 has to be somewhere in here because angle 3 and angle 4 are alternate interior angles. So I think they meant to say 3 and 4 because then that would allow you to use the transitive property, which is my correct answer for step 4.
But isn't 4 and 3 alternate exterior angles?
Yes, 4 and 3 are alternate exterior. That's why, right? So if 1 is congruent to 2, and well, I start off 1 is congruent to 4. Let's start with that one first. 1 is congruent to 4, and 1 is congruent to 2, and then what have we got? We have to connect 3, so angle 3 is congruent to angle 4 because they are alternate exterior angles. Then I can say that if angle 1 is congruent to 2 and 1 is congruent to 4, then 3 is congruent to 4 because they're all the same. Did that make sense? And somewhere I'm connecting these dots.
Wait, sorry, I'm so confused on what trend.
Okay, so first off, I say 1 and 4 are the same thing. If it helps, I'm going to give them numbers. So let's say 1 and 4 are 65, right? Just I made that up. Okay, then I'm going to say, okay, so angle 1 and angle 2 are alternate interior, so this one is also 65. Yeah?
Right.
Yeah.
Right. Then I can say, well, angle 3 is also congruent to angle 4 because they're alternate exterior angles. So 3 is also 65.
Yeah.
Right.
You see that?
Right.
Right. So then what we're basically doing is kind of connecting and going from point to point to show you that they're all connecting. So angle 4 is congruent to angle 3 because they are, wait, why is this even here? I don't understand why step 3 is here, honestly.
Yeah, just get that out of there. But 4 and 3, definitely giving like alternate exterior there, right?
Yeah, 4 and 3 are alternate exteriors. I don't understand. Like, that's just a very confusing step in there because I would say if 1 is congruent to 4 and 4 is congruent to 3, like, it just doesn't make sense why they would do so many extra steps.
So, like, what about 5? Is it just like there or
So
there?
step 5 would be the transitive.
Oh,
Basically, your transitive is going to be like your ending one when it comes to angles.
okay, that's fine. Yeah.
Oh,
Okay. What?
would transitive always be the ending one when it comes to angles?
When it comes to something like this where you're proving like congruency and you're like, well, this one's congruent to this one, so this one has to be, it's going to happen when it comes to proving angles, mostly because of all those rules, of all those alternate interior and exterior rules, that it's going to allow you to be like, oh, I can connect this to this side and then this side to this side. So then, because they're all going to equal each other, basically. Okay, so now let's see the flow chart. Oh, flow charts are pretty horrible. But as you can see, they are definitely a little bit different than the normal ones that we are used to seeing. So, but they're essentially the same idea. So we have, what number is this, 20? Right, okay, so 20. So now this one is like what you would see on the test, right? They might give you the flow chart and then they're gonna give you the options. I don't know, do they usually do a drag and drop?
Yeah.
Okay, then you might see it as a drag and drop. I'm used to seeing, when they give you the little button with the arrow and then it gives you all the options, but it's the same idea, right? Whether it's drag or drop or the drop down, it's the same thing. So I'm given that 1 and 4 are supplementary, meaning that they do what?
Equal
Up to 180.
They add up to 180, right? And then now I'm going to go ahead and start figuring this out. So I have the given information, right? I'm proving that A and B are parallel. That's my goal. So I'm given angle 1 and 4 are supplementary. Then I can say angle 1 is congruent to angle 2 and angle 3 is congruent to angle 4. And why would that be?
Vertical angles are congruent.
Perfect.
Yeah.
They are vertical angles. And again, you don't have to remember the whole rule, because they might say vertical angles are congruent. They might say vertical angles theorem. The point is that you notice 1 and 2 are vertical and 3 and 4 are vertical. So that's the answer you want to go with. Okay.
They're vertical.
Then,
Oh,
yes.
sorry, because I kind of forgot. They're vertical because they're cut by the one in the middle, right?
Well, the transversal is what creates all these congruent angles, but they're vertical because they're right across from each other. I know you when you hear the word vertical, you want to go like this.
Yeah.
But it's not. They're actually really diagonal from each other.
Okay.
Okay, so they're gonna be in like an X. So like if I had angles 5 and 6, those would be vertical angles as well. Okay. So now in this case, I'm given the reason, but I need the statement. Okay. So now I'm going for a combination, right? So this is what the flow chart does, is it gives you 2 separate reasons, and then it's going to combine it for you into 1. Okay, so knowing that 1 and 4 are supplementary, and knowing that 2 is congruent to 1 and 3 and 4 are congruent, what would I be using the substitution property to say?
See, I'm battling on supplementary angles are congruent or like corresponding angles are converse.
I think it's corresponding angles converse.
Yeah.
Because 3 and 4 aren't supplementary.
Yeah, they're not. So definitely.
Why not? Wait, well, 3 and 4, no, they are not supplementary.
No. So
I think it's corresponding angles converse then.
yeah.
Does anyone else have a guess? If you don't want to say it out loud, you can put it in the chat.
Wait, this is like supposed to be like covering like the whole thing. Like this is what they're trying to like summarize about the whole little.
What do you mean?
Like the thing that's about to go in the middle, it's about to say like everything about every angle. Like we're about to like summarize like what all this is talking about. You understand? No.
No.
Oh.
You don't have to summarize everything.
Oh. Okay, well, in that case, I would want to say like the consecutive interior, but like not everything is like inside. But only thing I really know is like corresponding angles are converse. So yeah. But if I'm wrong, like just give me like a hint, put it in the chat.
You're wrong. You're wrong.
Oh, okay. Well, could it be
Here's a hint.
Could it be vertical angles are congruent?
No, we already used that with this one right here.
Oh. Yeah, right.
Would it be like it can't does it have to be one of those like theorems, or does it have to do with like the ones with the numbers?
Right, so it has to be something from down here, right? I already used vertical angles are congruent, so I'm eliminating that one. So now, and you're right, Violet, you're kind of making that connection. These converses and the supplementary angles are congruent are actually reasons. They're not statements being made. Statements being made are directly about the actual image we're looking at, the actual thing we're trying to prove. And the reason is the why. Did that help?
So, is it consecutive interior angles? What's up?
No. Didn't I just say those are reasons, not statements?
Okay, so it has to be corresponding angles converse.
Oh, it's angle 2 and angle 3 are supplementary.
What?
There it is.
What? Okay, hold on. No, you're lying.
All right, you ready?
Yeah.
So I've already said angle 1 and angle 4 equal 180, correct?
Yeah.
Right underneath that proof where I said it, I then said angle 2 is congruent to angle 1,
right.
and angle 3 is congruent to angle 4.
Oh.
Okay?
Yeah.
So by substituting angle 1 and 4 with 2 and 3,
oh, okay.
they
Yes.
have to equal 180.
So you substituted 1
That
and
makes
4.
sense, yeah.
You substituted 1 and 4 with 2 and 3.
Yes.
Oh, because they're like kind of like the little same thing there.
Right.
Oh, okay. Gotcha.
There we go.
Gotcha.
So, but you see what I'm saying? How the bottom parts here on the lines, the given and the substitution property, those are all reasons.
Yeah.
They don't talk about the actual proof you're doing. The top is what can change. Angle 2 and 3, angle 1 and 4. That's going to change based on what you're proving.
Right.
Okay. So now I can eliminate this one. Now I have A is parallel to B. So I'm now looking for a reason. So what would my reason be?
Consecutive interior angles.
Yep. She
Yes.
just took it right off my mind. Yep.
Consecutive int angles. Converse. Because remember, the converse says if you have consecutive interior angles that are supplementary, then the lines are parallel. Okay. There's one more thing I want to go over, just a reminder, the transitive property. That's when you have if A equals B and B equals C, then you can just say A equals C. Yes?
Yes. Thanks, mathematician.
Okay, perfect. So now, oh, look at all of these proofs. Ty, you know, aren't you so happy right now?
Yes, because I get to practice them.
So there we go. Okay, so look, this one is only 3 things. Okay, I want you to try and figure it out on your own first. And then we're going to go through it.
Ms.
So
Prev,
yes.
after this, like, can we also do like circle formulas?
Yes, we can do some circles.
Okay, thank you.
Mm-hmm. Or actually, Violette, what I wanted to do is focus on one of the 3 things today.
Okay.
So since we started the theorems, and then for those of you who are here, so that hopefully you hear it, because you know I probably will forget on Friday because I'm old and forgetful. On Sunday is the other tutoring session at 5:30, where I will do another one of the 3 topics. I think it's maybe like the congruent similarity one. That's all on triangles. Or maybe I'll do the coordinate. I'll do circles on Sunday. And then on Monday, I'm going to do the 2-hour tutoring at 6:45, covering the congruent similarity stuff, and then an overview of everything. Okay. And if you attend all of those sessions, you will get a total of 5 extra credit points. So now what that means is that, like, for example, let's say Joshua has a 75% at the end of the 9 weeks.
I don't, by the way.
He does not, but let's say he did. And he attended all of these tutoring sessions. I will override his grade and put in those 5 points to get him to an 80%. So this is like a big extra credit boost I'm giving you guys.
Hey, thanks.
This
Okay.
the one that you do the overview on everything, that's Monday or Sunday?
That's Monday, because since it's going to be 2 hours, the first hour will be congruency and similarity, and then the second hour will be everything.
Okay. And what if you just join on one of those hours?
Like if you can only make one or the other?
Is that still fine?
Yeah, that's fine. It's whatever. This is for you guys, you know? I'm doing it for you guys.
Okay, perfect. Thank
So
you.
is this like, what day is this? Like, what time?
Oh my goodness, Joshua.
I'm sorry. I know
Monday.
someone Sunday?
You,
oh,
okay.
Monday.
Okay. Okay. Shit. Stop.
Sorry.
Sunday, 5:30 p.m. Do
Right.
not show up here at 5:30 a.m. or message me on Reminds asking me where the Zoom link is.
Okay.
5:30 p.m. on Sunday. Then on Monday, 6:45 p.m.
Okay.
Got it?
Yeah, got it.
We all wrote it down on our calendar.
Just wrote it. Yeah.
Okay, perfect. If you remember, and I might remember, I don't know if I will, but if I remember, I will tell you guys during the boot camp on Friday. Remember, your boot camp is Friday.
Yeah.
So.
Ooh, yeah.
And there will be a whole session just on proofs and constructions with Monteavaro. Not with me. I got out of it this year.
Wait. I'm sorry. I'm just like on this problem thing. Is 3 transitive? For like,
Did everyone else already finish it?
Yeah.
like one okay. Oh, you guys finished it. Oh.
Well, I want to make sure we finish it before we start going over answers.
Oh,
I'm about to finish.
Okay.
great.
I get it. So. Just to confirm, reflexive is the opposite, right?
Yes. Well, reflexive is like ADDA.
Oh, okay. And then symmetric is which one again? Sorry.
ADAD.
Okay, thank you.
Right. Reflexive, think of like a mirror. You know, if you raise your right hand, your reflection's left hand goes up.
When everybody's like done, can I like throw a little shot at it? Eh?
What?
Sorry, I was like, when everybody was done, like, can I throw a little shot at it, like, see my little guesses and everything?
Oh, are we ready? Violette, we're good?
Yep, I'm done.
Okay, perfect. All right, so the first one, what do we have for the first one? Joshua.
Let's say it all together, guys. Vertical angle congruent.
What?
No.
It's
Given.
Wait, no, sorry. That's why I put for the second one. The second one. For CBD, BFE, given. Ooh, said that.
It's right here, given.
Oh. Okay,
All
so
right.
I thought it was like something else. Wait, what? How do you know if it's something like given? Like, what do you mean just given? Like, how you just
Like it tells you.
yeah, it says in the like it says that you're given.
So it would either say given, like how we have it here, where we've been seeing it, where it's like given, prove. You might also see it as this part up here. In the figure, CF intersects AD and EH at points B and F. They might have said, not in this example, but in another one, they might say bisects, right? That means that it goes right into the middle.
Yeah.
Or they'll say this figure is a parallelogram.
Mm-hmm.
So then you use that information as given.
Oh, okay.
Okay. All right. Now the next thing was CBD. So CBD and ABF.
Yeah.
And what?
Someone typed in chat vertical. Is that right?
Yeah, I already. Why, Vienna? I already answered that. We're good with that, or do we need me to say it again?
Yeah.
So the second one is vertical.
So the second one, thanks to Joshua spoiling it a little bit.
Yeah.
Vertical,
Okay.
vertical angles are congruent.
Yeah, I typed that in chat. Yeah. Thanks.
All right, and the last one is ABF is congruent to BFE.
Is it transitive property?
Yes, it is the transitive property.
My answer. Thanks. Yeah.
Because again, I'm going CBD BFE, CBD ABF, therefore ABF and BFE. Right? Same thing. If A equals B, B equals C, then A equals C. We're good with those?
Yes.
Right, ready for the next one?
Yes.
Yeah.
All right, so now this one, I'm missing one reason and I'm missing a statement, okay? So now I want to point this out because I've pointed it out in other sessions, but it's usually only one person in the tutoring session. So I'm going to point it out again now. In this triangle proof, right? We see it's triangle, okay?
I got the answer. Oh, sorry. Oops.
Oh, wait, this is not related to the question they're asking. This is just an additional fun fact, we'll say. When you have a triangle proof, and there is a step after a triangle congruency theorem, that's the SAS, SSS, ASA, all of those. If you have a statement after a proof of triangle congruency, the reason will always be corresponding parts of congruent triangles are congruent. This statement is only done after you have proven congruent triangles, okay? So I don't want you to like see that and be like, oh, these are congruent parts, and then go and put that one. That one is saved for at the end, okay?
The yellow?
The yellow one, yeah.
Okay. So that's always going to be the end of the proof.
That will always be at the end after you've proven that the triangles are congruent. Okay?
Mhm.
All right, so given that CD is the perpendicular bisector of AB, prove that DA is congruent to DB. So first of all, they give me that it's a perpendicular bisector. A perpendicular bisector means it does what?
Intersect each other.
Degrees.
Makes 90 degrees. I'm pretty sure that's what was said. All right, so AC is congruent to CB because it also divides it evenly in half. And then the two angles are 90 degrees. Then I have DC is congruent to DC. Which property is that one?
Reflexive property.
It is going to be the reflexive property. So automatically I have eliminated options A and B. So now I'm looking at the reflexive property. So now the last thing says something by SAS. So that means I'm now naming the two triangles, right? Remember, the triangles have to be in the same order. So I'm going from, we have DCA and DCB. Did those go in the same direction?
Yeah.
Yeah.
Yes. So then my final answer is
C.
Yeah.
C. Yes?
Vienna asked, why is 3 reflexive?
Oh, yes. Okay. So 3 is reflexive, and I know that we're just talking about the reflexive and the symmetric. So the symmetric and the reflexive, I don't really like those properties because I feel like they don't follow their own rules. But I know this is not a transitive property, right? Because I'm not saying something is congruent to something else and then something is congruent to something else. It's the same line is congruent to itself. And I'm pretty sure we looked it up one time in second period. Let's see if we can. Reflexive versus symmetric property.
I have a question.
Yes.
So I was like practicing for the EOC on IXLs, and there was like choices that had reflexive property and then also reflexive property of congruence. What's the difference?
So the reflexive property of congruence
Mm-hmm.
is going to be, hold on, wait. Before I lose my train of thought.
Okay.
Okay, I swapped it. Reflexive is DC congruent DC. Symmetric is DC CD. Does that help? I swapped it. Okay. So the reflexive property of congruence is basically that it's congruent to itself. So like AB and AD on a triangle. So like, say I had something like this.
Oh, I see what you mean.
BAC. Yeah, you see how it would like fold over?
Yeah. Okay.
That's what. Mm-hmm. Okay. So moving on. Wow, we stumbled upon all the proofs today. The last time I did proofs, it was just you and me, Violette, right? No, we only could find like 1 or 2 here and there.
Yeah.
Now it's like all back to back. Okay. All right, try this one out quickly on your own. And then I really want to do number 24. And while you guys are doing that now, today I won't be too mean about it. But in the next sessions, I do need to see participation for you guys to get the extra credit points. Because like not obviously not you guys, because like Vianet is in the chat and you guys are all answering. But someone might sneak in here and think they can just join the Zoom and not say anything. Like Leia over there. I was expecting Leia to answer. She didn't even answer. See, I was just messing with you. Hi, Leia. I hear your voice through the chat. We have our answers?
Yeah.
I have my answer, but I'm just trying
Yeah.
to remember what was the substitution property of equality again?
So that's the one when you can replace it with something that you already proved was.
Oh, okay, yeah. Okay.
Okay. All right. So what do we think? Put your guesses in the chat. I don't want you to say it out loud.
Mr. Domo, I have a question about the EOC.
Yes.
Is it like the fast, like where if you don't finish in the allotted amount of time that you get like extra time?
Yes. Everyone gets extra time.
Yay.
And you all were correct. It is D. So obviously they add up to 180. So that's going to be supplementary. Yep, that's supplementary. And then you have this substitution property of equality. Well, just before I had said ABD and ABC and CBE and ABC are supplementary. So if I'm then talking about substituting, that means I'm going to kind of replace something with something else. Well, if they both add up to 180, I can technically say that they add up to each other. Okay? So that's why D is the correct answer. All right, number 24. Oh, there was something I was going to say about the EOC. Remind me at the end.
Oh, Mr. Domo, I'm sorry. I'm a little new here. How long are these things? Oh, and is my mic a little too loud?
No, it's fine. No, there's only 10 minutes left. It's only an hour.
Oh, okay, that's not bad. All right, thank you.
Yeah. All right, so we have complete the proof of the vertical angles theorems below. So given 2 and 4 are vertical angles, prove that they are congruent. So this is, what kind of proof is this? We have the flow proof, we have the column proof. Which is this one?
Complete the proof. I don't know.
Not complete the proof. It begins with a P.
Perpendicular?
No. What do we think? Look at it. Think about it.
I have no clue.
Take a guess at a letter.
E. I don't.
A.
Lots of A's.
Wow.
Think about it. L? No, no L.
I's.
Nope, no I.
E's.
Nope.
T?
T?
Yeah.
Nope.
Oh.
R. Parallelism.
Wait, parallelogram?
No.
Oh,
Pair.
Parallel?
No.
Oh wait, no, you literally said there's no else. Sorry.
Para.
Is there a D?
There's no D.
What the heck?
What?
um, hmm.
Leia, Vianette, you want to put a guess in the chat for a letter? We're just trying to figure out what this kind of proof is called. No, no D.
Is there a H?
There's an H.
Wow.
Yeah, no, I'm gone. I don't know.
What about an N?
Oh wait, is it? Wait.
Not a math term.
Oh. What?
Yes, Leia's got another one.
Paragraph.
Paragraph.
Oh.
Oh,
It is in the format of a paragraph.
Oh, okay.
I want you guys to know all the types of the proofs because I don't want it to be that the question shows up on the test and you're like, what am I looking at? You know, I don't want the panic to sink in. This is just another proof, right? It's just another one. All right, so in the diagram of intersecting lines, 2 and 4 are vertical angles. Also, 2 and 3 are a linear pair, and 3 and 4 are a linear pair. By the linear pair theorem, 2 and 3 are what?
Wait, where did you get linear pair from? I thought it was supplementary. Wait. Oh wait.
They're the same thing.
Oh, sorry. I thought you. Yeah, no, never mind. I was moving on.
So remember that paragraph proofs are going to be a little bit wordier just because they're turning a proof into paragraph form, right? So by the linear pair theorem, 2 and 3 are what? Here's my options down here, by the way.
Supplementary.
Yeah, they are supplementary. And 3 and 4 are
Supplementary.
also supplementary. Then if I add up 2 and 3, I get 180, and 3 and 4 equals 180 by the definition of
substitution property.
Of equality.
what? No,
Wait,
supplement.
what?
Substitution property of equality.
It's
Oh.
still
Wait, what?
Transitive.
Subtraction property.
What?
Okay, great.
Oh, yeah. Okay, yeah.
Wait, what?
It's still
Oh.
supplementary.
So
because
the second one is substitution, right?
No, it's subtraction.
Oh,
All three, the first 3 fill in the blanks are all supplementary because they're all talking about the same thing. Again, paragraph proofs are wordy. So you might see the same thing rephrased like 3 or 4 times. Right?
Okay,
So now,
like reuse the same words.
yeah, they'll like look, they changed it. They said, okay, they're vertical angles. Then they said they're a linear pair. By the linear pair, they're supplementary. Then if I rewrite it as adding them up and equaling them to 180, they're supplementary. You see how they kept saying it in a different way? Like where the number 23, where it kind of combines. I mean, it's like steps 1 and 2 in question 23, and they broke it down into like 3 or 4 sentences rather than just 1 and 2. So then, by the blank, the measure of angle 2 plus measure of angle 3 is equal to the measure of angle 3 plus the measure of angle 4. So by which one?
Subtraction property of equality? Or substitution?
Okay, so it's not any of those.
Wait, no, transitive.
Oh, yeah. Wait.
Transitive.
Wait, I have a question because I was gonna say like I had thought it was transitive, but I thought that transitive had to like because you know how it says
Yeah, I don't like this. This shouldn't
yeah
be.
because it I thought that it would say like it would only use it once instead of twice. You know what I mean?
Yeah, so based on actually when you read this, and even looking at question 23, right? Question number 4, we did the substitution property of equality, and we basically did exactly what they're doing down here with the measures of the angles. So I think it's supposed to be substitution property.
And then though using the transitive property would be the answer one.
And then not transitive property, because look, what do both sides of the equal sign have in common?
Oh, angle 3.
Angle 3. So if I were actually solving this problem algebraically, what would I do?
Substituted.
Not substitute it. Like let's say I had 2x plus 3y equals 3y plus, I don't know, 4x. We're just making it up. What would I do? Get all the x's to one side, all the y's to the other side, right?
Yeah.
And how would I get rid of the y's?
Divide.
Are you sure?
Wait. No, hold on.
If I'm moving it, yes, we cancel it out, as Leia says, but how do I cancel it out?
Oh, you subtract 3 from one side and then y equals 0.
I would subtract 3y from both sides, and then what happens, as Ty says, they equal 0. Same idea over here. If I subtract measure of angle 3 from the measure of angle 3, wouldn't that cancel out?
Yes.
So then which property is getting it to be 2 equals 4?
Subtraction.
Subtraction.
Wait, but then I'm confused on. Oh, wait. No, I am confused on what the difference between transitive property and substitution property is. Because you said transitive is A equals B and B equals C, so then A equals C.
Right. So now the difference here, let me erase over here. The difference here is that the question says that I have the measure of angle 2 plus the measure of angle 3 equals 180. And I have the measure of angle 3 plus the measure of angle 4 equals 180. So the transitive property would have said, because these two equal 180, right? And then 2 plus 3 has to equal 180, and 3 plus 4 has to equal 180. Then 2 plus 4 equals 180. Or rather, 2 equals 4.
So
that's the transitive. That's saying that basically the transitive type is that you have to have something from the previous matching in the bottom. Right? So I have this one here and this one over here matching.
but is that not what you have?
Well, the difference is that I went from going to adding them up and equaling them to 180 to saying that they equal each other.
Oh, okay. So it's not transitive because it's not equaling up to something?
Right, because it doesn't, I don't get rid of the 3 the way that I normally get rid of the 3 if it was a transitive. I'm getting rid of the 180. I'm substituting 180 with this other equation.
Okay. So for it to be transitive, the equations would be like on their own.
Right. If it were transitive, they wouldn't have even mentioned the 180. They would have just said, if the measure of angle 2 equals the measure of angle 3, and 3 equals 4, then 2 equals 4. But they don't say that.
Okay. Wait,
So,
I'm gonna have to see one that's transitive again. But I guess I could ask you in class tomorrow.
Friday, because I won't be around.
Oh,
Boot
yeah.
camp. Boot camp tomorrow for Algebra 1. And actually, I think this is going to be the end. But a little bit of homework for you guys. But if you do this little bit of homework, I will forgive one IXL assignment.
Whoa.
Yeah. So all you have to do is answer 25 and 26. I'll leave it up for a second if you guys want to take a picture of it. It's on Schoology, so you can get it through there as well. But I'll leave it up here for a second. So remember, get this done, and I will excuse one IXL. So like if you've done like 3 out of the 5 and you just can't do the last 2, and you do these extra credit questions by Friday, yes, BNF, by Friday, and you do these 2 questions, I will give you the 4 out of 5, meaning you would have a B instead of, I think it's like a D if you do only 3 IXLs.
Wait, but are there gonna be more IXLs after this?
No, Friday is your last IXLs.
Oh, okay.
If you've done all your IXLs,
I have.
then I think, I know you have time. Then I will just give you an extra credit, like somewhere else.
Okay.
Is this week 10?
This is it. This is the last week.
Oh, well, okay. I'm gonna have to do my week 10 like today.
What, do you want to do IXLs after your EOC?
No.
Okay, that's what I thought. All right, did everyone get this picture of
Yes.
Okay.
Yes.
Okay.
Thank you.
Wait, before we go,
Yeah.
stop sharing. Let me stop recording.